GTC last week was full of hardware talk. Lots of announcements of bigger this and faster that and more of those and more of these. But one new piece of software aims to make AI workloads even faster. NVIDIA Dynamo is the name of a new operating system aimed at reducing latency with AI requests and optimizing both the translation and return of results. Dynamo is a suite that will optimize requests from various inferencing engines, such as TensorRT and SGLang, along with a large number of GPUs concurrently. Dynamo is also designed to work with frameworks like PyTorch, so you don't need to recode everything that you've released as code on GitHub or as pre-built container images. Tom, what makes Dynamo so dynamic?
In order to understand what they did here, you first have to understand how an AI system processes what you feed it. So we focus a lot on what the AI system feeds us, right? The tokens that it kicks back. But it starts before that. So you break this down. The first part is what they call the prefill. That is when you type in a prompt and hit enter, the system has to figure out what you're asking about. It has to translate that prompt into whatever it's going to translate into, whether it's a SQL query or something else. Now, what you get back from a token perspective is called the decode. And that is, oh, well, I found these results, or I wrote your, essay on all quiet on the Western Front, or what have you. So if you think of prefill as the input and decode as the output, what Dynamo is doing is it is allowing for the prefill and the decode to be decoupled from each other and spread across a whole bunch of GPU workloads. That is very important, because if you tie the prefill to the decode and tie that, even if you could tie the prefill to the decode and then have to spread that across a certain number of GPUs, you're going to run into a problem, because do I allocate the same number of GPUs for both of those tasks? I would argue you need far fewer of them for the average prefill than you do for the average decode. But here's where it gets even screwier. There are workloads that are asymmetric. So think about the average person using a tool like ChatGPT to ask it what I would consider to be dumb questions. Those are like, when they're using it like a search engine, or they're asking it to spell check something or whatever. Those are a lot of little decodes, right? Simple prefill, simple decode, but they're everywhere. So you want to grow horizontally there. You want to have as many resources available as possible to answer those as quickly as they can, but you need to make sure that they're all decoupled so that you're not tying up any in one individual GPU resource, right? But then think about the way that there are certain people who use it. Maybe you're feeding it a really complex image query, or your prefill is very complicated. Like those things where like you hit enter and it has to chew on it for like 3 minutes before it even acknowledges that it received the prompt. And then it has to do a lot of work on the back end to give you the decode. That would be what I would consider more of a vertical workload, right? It's going to take a lot of resources, a lot of time to build on that. So you're going to tie up more of those. There, you need more prefill resources in order to make that happen. What NVIDIA did is they basically wrote a system to figure that out for you. Like, you put Dynamo in front of your clustering and it will decide, do I need to scale horizontally? Do I need to scale vertically? How much do I need to do on this prefill? How many GPUs do I need to spread it across? Oh, this looks like a really complicated decode. I need to spread this further and wider. And it all runs magically on some customized version of Linux. And this is where NVIDIA is going to start trying to do hyper optimizations for all of those AI workloads. Doesn't matter what you're going to feed it, whether you're feeding it Llama, whether you're feeding it, Claude, whether you're whatever you're giving it, whatever the model is, you need to optimize for all of those different dimensions of how it can be, far, wide, tall, short, whatever. And the fact that they're basically coming out and saying, all you got to do is download our code and put it in there, and it still runs with PyTorch, and it still runs with TensorRT and SGLang and all these other things that you've been building. We'll do the work in the background. And I don't know if you've noticed this or not. Maybe you're not a coder. I know I'm not, but I have noticed this weird thing. When you handle those kinds of things for people who write code, they stop writing code that optimizes for handling those things. It's like I've covered this before on some things, but like when Facebook engineers wanted to rewrite a routing protocol because they're like, well, why are the hello packets only 512 bytes big? Our links are way bigger than that. The hello packets for this other routing protocol are only 512 bytes because we used to work in systems that had less than 1K that it could transmit in a particular packet. So people are going to start coding their applications and become reliant upon Dynamo to spread those things around, as opposed to hoping that you've coded it correctly so that you're not tying up too many GPU resources, which of course just means more money for NVIDIA in the long run, because Dynamo is really optimized to run on their hardware. And we'll see what happens. But props to NVIDIA for not just saying throw more GPUs at it and it'll make sense. So I got to give them credit for that.